Thanks very much. Thanks everybody for joining. Yeah, it's my first time talking here at the Osnabrück C++ meeting. I just stumbled across a tweet from Tina last week, so I kind of had to rush preparing this presentation. It's a C++ technique I developed a couple years ago, and I just used it in a recent project, and I wanted to talk about this at the company for the colleagues who would like to use that also. So that was quite a good occasion to speak about those link time plugins. Down here on the screen, you see some links. So the code is on GitLab. You also find it on GitHub. And the slides, this is what you're just seeing now, they are also on GitLab. And I think we'll post the links to the meetup and to Twitter, and I think this has already happened. So you will have no problems seeing that. This will not be a total slideshow, of course. I don't really like all those slideshows where I see a lot of slides, but no practical coding. The slides are just for introduction, explanation, what it is, what problems it solves. And then we'll have a look at real code and have a look at the C++ code with a real demonstration program, which is self-contained and which gets the thing across, I hope. Okay, it's my first time here in your group, so let me say a few words about me. I've been doing this for a while. Actually, I've been in professional software development since over 30 years. I've developed quite a few very large software applications in the industry with some security issues, safety issues even, of the style when the software failed, a whole factory would sort of fail. And under bad circumstances, maybe even people could get hurt or could get sent to prison for some reason. So that led me to developing quite an awareness for good software quality. Quality begins when you have good coding style, clear coding style. Code should be very simple, but should still get the job done in the best way possible. And of course, I do all the quality stuff, starting with unit tests, integration tests, CI, and everything that has to do with it. Yes, in the former company, I was head of software development at some point, CTO at a later point, but management wasn't quite my piece of cake, so I returned into development. I'm currently working as a software engineer at Develo. You might know the company. They do this Powerline communication thingies, which you may have seen. We're going to see one in a minute, because this is actually where my example application comes from. Because I was working on the firmware for these devices, and that's where I was using those link time plugins. I'm also software quality architect at Develo. That means everything that has to do with software quality is my responsibility. But today I'm not talking about software quality in itself, although, of course, I understand software quality to be something that engulfs everything, starting with good coding style, starting with good software architecture, starting with having everything just once in your source code and preventing people from making mistakes, which is maybe the most important topic in software quality assurance, because everybody can program, but nobody's perfect. And we make mistakes when writing software, and in particular when modifying software. So when you have to change something in 3 places, you will eventually forget one of them and change it in 2 places only. And if you do that, either the build must fail, or unit test must fail, or something else must fail, but it must not be possible that you get a working program when you forget something like that. And that is kind of what the link time plugins are about also, because I was looking for a solution for a particular problem, and there were solutions, but I wasn't satisfied with them because they would not have satisfied that condition. Okay, let's get right into it. Yeah, these are the devices I was writing the firmware for. Yeah, just for the motivation, what we are about to accomplish. This is not an advert for Develo, but this is just to explain what I am talking about and what I'm working on at the moment. These are Powerline adapters. So you put them into a wall socket and they will establish a connection from one to the other over the power line. So you can connect your Fritzbox or whatever DSL router you have to one of them and connect your computer to the other, and then you are online in the internet. This is how Powerline works, and some of these have a Wi-Fi interface, so you can use them as a Wi-Fi access point or repeater or mesh server or whatever you want. And what I was working on is an API for those devices, HTTP API, so you can sort of remote control these devices. So you can issue queries to URLs which look a little bit like this. By the way, if you have developed devices, these are not the actual URLs. They are tailored a little bit, they simplified a little bit, so these will not work on your devices. But this is just as an illustration to give you an idea of what we are talking about. So here you see the URLs for 3 different API endpoints. One is called set device name, which changes the name of a device. One is called start PLC pairing, which starts the pairing procedure on the Powerline interface. And the third is called start Wi-Fi WPS, which starts the WPS procedure on the Wi-Fi, so you can get a new device into your Wi-Fi network. And as you can see, those URLs consist of 2 parts. And one part is the white part here. It's identical for all the URLs. And one part, it's the colored part, which is different for all of them. And of course, the white part is handled by a general infrastructure inside the firmware. There's the web server component and some libraries which handle this /API path in the URI, which check the version number and do a lot of stuff with encoding and decoding parameters and all the stuff I've left away here. But that's the general purpose component, which is in a library somewhere. And the colored part is what's actually specific to the device and to the endpoint. So at some point in the source code, there is one C++ function which sets the device name, and another which starts the pairing procedure. And that means that somewhere in the program, there is a transition from the general purpose part into the special purpose part. And what I was thinking about is how to do that transition in the best possible way. Well, of course, that doesn't sound awfully difficult. So the first thing we would come up with is something like that. So we have a function somewhere, which is called handle endpoint, which is somehow called from the library layer, from the web server, which has done all the parsing and which is now saying, okay, please execute this particular endpoint. And the name which is coming to the function is the final part of the URL, the name of the endpoint we want to execute. And what this function does is simply test this string against several predefined strings, the ones we have seen before: set device name, start PLC pairing, start Wi-Fi WPS, invoke the respective function and return its result. And if none of them matches, returns a 404, which in some way will be returned to the web client to signal that this was the wrong name for the endpoint. Okay, easy enough. But well, that doesn't sound like a very bad solution, does it? I mean, it's straightforward, it's easy to read, it's just 3 endpoints. And if it was just those 3 endpoints and nothing else, I would probably have left it at that. However, imagine you have a dozen endpoints. Then, okay, then you have a long list. And of course, I would put the if and the return on the same line, so it's looking less confusing, taking less space on screen. But what do you have to do when you add a new endpoint? So, you know, when you add a new endpoint, you have to implement the function that implements the endpoint. Like set device name, you have to write that function and put it somewhere. This is the first place where you have to put the implementation. The second is you have to declare the function somewhere where it's so that it's visible in this handle endpoint function. So this is the second place which you have to change when you add a new endpoint. And the third is you have to add it to this list, which is the third place where you have to make a change when you add a new endpoint. And there will probably be more. For example, there may be some function which iterates over the endpoint and lists them. We have something like that when the program starts up. It prints lists of all the endpoints for debugging. And this is the fourth place where I have to enter those endpoints. And you may have some HTTP query for introspection, which returns a machine-readable list of the endpoints with some additional information, maybe. So this is the fifth place where you have to add your new endpoint. And that's getting tedious. And that's what I would call not a good solution, because this is exactly the situation I've described before. When you add something, when you change something, you have to remember a lot of places that you have to change, and you will definitely sooner or later forget one of them. So you have to put unit tests into all of these to make sure you didn't forget it. Or you have to put integration tests which check all of the possible ways to get the lists of endpoints and all. But then you have to add your new endpoints to the unit tests or to the integration tests, which is place number 6 and 7 and whatever, where you have to add your new endpoints whenever you add one. So it's just getting worse. And what I was looking, by the way, and it's getting worse still, because we're having a problem here. We have a lot of different devices which we support in the firmware, and there is a specific firmware image built for every device type. For example, we have devices that don't have a Wi-Fi interface. And we build a special firmware for those devices that don't have a Wi-Fi interface. And we even have devices that don't have PLC. They only have Wi-Fi. So on these, we build a special firmware with no PLC functions in them. And that means the code as you see it here would not even be compilable on a non-PLC or a non-Wi-Fi device, because those functions, start PLC pairing, we don't even want to get them into these devices just to save space in the firmware. So, and we don't want to put something into the functions which simply returns or if deaths them out, because we can't even compile these functions, because to compile these, you need to compile some other libraries, but you can't do that on those devices. Okay, so what we would end up with, something like that. You see, handle endpoint now has 3 sections, and the first contains the endpoints that exist on all devices. The second has a #if has PLC for the PLC endpoints. The third one for those which have Wi-Fi, and there may be more of these conditions, and that makes things even worse. Now you don't have to remember to add your new endpoints to half a dozen or more locations in the source code, but you also have to remember to put them into the proper preprocessor section. And when a new device type is added, which may have some different criteria, you have to add that criteria to half a dozen places. This is getting out of hand totally. What I was looking for is a very simple solution. And I don't want to add my new endpoints into 5 or 6 or 7 different places. I want to add them in exactly one place. And I want a second place where I decide into which firmware versions this endpoint goes. So this is the absolute minimum that you could go. You have to implement the endpoint once. Of course, you have to do that. But you implement it once and be done. You don't have to put it into some list somewhere. I didn't want to do that. Just implement it once. And of course, we have a build configuration for each device type. And somewhere in the build configuration, I want to say which endpoint goes into which device. Again, at exactly this one spot and at no second spot. Okay, that's exactly what I wanted to do. That was my requirement. And you cannot do that with these, let's call it naive if-else chains. What we want essentially is something like that. So the handle endpoint function doesn't know anything about the endpoints, but it retrieves a list of endpoints somewhere. It iterates over the list, looks for the list entry with a particular name, and just runs a function on the list entry. Okay, and there could be more functions for these list entries here. We have a name function, an execute function. There could be more depending on what other functions you have available for every endpoint. And you can do this in several places in the source code. And this solves one problem already. When you have to iterate over the list of endpoints several times, you do it several times, but you don't have to change each of these source locations whenever you add an endpoint. Okay, that of course means that you have to maintain your list somewhere. And I still didn't want to do that, because that would mean I have to add my new endpoints in two places, in the implementation and in the list. And I didn't want that. But what I wanted to do is actually, my idea was to have a plug-in architecture. And you know plugins from, the real web servers. For example, you have these Apache or Nginx web servers, which do exactly the same thing. They serve URLs, but the path of the URL is in no way hard-coded inside the source code. For example, you don't have to recompile the web server that runs Wikipedia whenever somebody adds a new Wikipedia article, because that's all done by plugins. And those plugins are somewhere in the file system in a wider sense, and the web server picks them up and automatically reacts according to them. So you have a plugin architecture which creates a very clean isolation between the application, the general purpose part of the application, and the plugin part. And that's another benefit, isn't it? Because isolation is a very good software quality criteria. You see, in the previous versions of the handle endpoint function, we had another problem. That function knew about the endpoints. So that function didn't belong to the general purpose part of the software because it knew the endpoints, but it didn't belong to the special purpose part either because it was called by the general purpose part and probably linked into it. So it was something, a gray area in between, and that function broke the isolation layer. And what I had in mind was something which had a perfect isolation. And those plugin architectures, they do exactly that. They isolate the general purpose application from the special purpose implementation of particular endpoints. Or let's call it plugins, because that's what it's all about. You have plugins for the API endpoints. In our case, you may have plugins for other stuff. For example, I once used the same thing to have plugins for command line parameters, because the software was built in particular ways, and command line parameters were handled in a very complex way. And depending on what kind of thing happened during compilation, you had more or less command line parameters. And I didn't want to keep a list somewhere, so I put it into these link time plugins. Okay, now plugins are not a new idea, of course. They have been around for a while. And there are a lot of techniques how to do them. For example, you can compile your plugin into an SO, static, a shared library, shared object file, which is essentially a dynamically loadable library. And you iterate over the files in a certain directory, and you load the libraries, and then you sort of work with them. That would be one way. Another would be to have a scripting language. I once had a TCL interpreter compiled into the application, and all the plugins were TCL script files on the hard disk. And we just load the files from the hard disk at runtime, and then we could run the TCL scripts, which is a scripting language which is very well suitable for this case of this kind of thing. But you could just as well use regular executables or shell scripts or whatever you have. That, however, would have been a lot of overkill for my particular application, because we're in the embedded world, and we have a firmware which is installed on the device, and it doesn't change from there on. So why compile a lot of applications just to ship a lot of executable files? why have an infrastructure that makes it possible to install and remove plugins at runtime when that never happens? We never install a plugin or an endpoint or anything on an existing device. If we do that, we install a completely new firmware image. So that would have been total overkill. I was looking for a much simpler, much easier solution, and I was looking at something that was not runtime dependent. For particular reasons in one of my previous projects, runtime plugins were totally out of the question. I had to have a single executable that contained everything, no external dependencies. So that's exactly what I wanted to do with the plugin system I needed. I wanted the flexibility of a dynamic plugin system with a complete static build and everything linked into the executable. So in other words, I wanted link time plugins. That is, plugins which are plugged into the application, not at runtime, but when the application is linked. You could also call them build time plugins, but build time includes link time as well as compile time, and it's important that the decision which plugins go into the application is done at link time and not at build, not at compile time. Okay, that's an important thing, which was a requirement that had to fulfill. So that's where the term link time plugins comes from. Okay, so far about the question what link time plugins are, and what they are good for, what problems they solve, and where they can be used, and of course also where they cannot be used. You cannot use them if you need some sort of runtime dependency. Whenever you change something about the link time plugins, add a plugin, remove a plugin, you have to rebuild your application. That is exactly how this thing works. Okay, so far about that. That was everything I wanted to show you from this presentation. And now let's get into the example how I solved this. As I said before, this entire thing is on GitHub and GitLab. I've showed you the link before, and what you see here is the GitLab repo. Okay, and you can find it on GitHub also. I mirrored it into GitHub. It's even on the Devolo GitHub page. That's very interesting because I originally developed this thing for Devolo, but Devolo has a very cool attitude toward open source. We use a lot of open source in our development, and we like to pay back into the open source community. So whenever we change something in an open source project, because we have to make some modifications to it, then we upload that back into the original repo. So we contribute to the original project, and sometimes we even open source our own code. And this is one example. And that's also the reason why I'm allowed to talk about this today. It's no longer proprietary code, but this is now open source code for everyone to use. And this is a look into the repository, which you can download from GitLab or GitHub. At the bottom, you see one file called linktimeplugin.hpp. Quite a short one, actually, just 4K. And yeah, that's the whole thing. That's the entire link time plugin library. It's a header-only library. So in order to use the link time plugins, all you have to do is copy this file somewhere into your include path, and then you're set. There's a README file and a license file, and the rest is just a demonstration program. By the way, the README file explains everything I'm telling you at the moment, just with different examples. So if you need some information, just read it. It goes into quite a lot of details. Finally, the README file is a lot bigger than the actual header file and the demo files combined. That's cool, isn't it? Anyway, we'll now have a look at this demonstration program. And first, I'd like to issue a word of warning. I made experience with some people, especially C and C++ programmers, who, when you have a versatile solution to a complex problem, which we are having here, who expect a certain complexity and a certain amount of things being complicated, things being difficult. And sometimes people are confused when the solution is very easy and doesn't include a lot of boilerplate or a lot of very complicated stuff you have to copy around into source files and you don't really understand, which makes the impression of being highly sophisticated software. For this thing, for this demo program, and for link time plugins in general, I'm afraid that's not the case. You will see very little boilerplate. Using this thing is ridiculously easy, but it still fulfills all the stuff I talked about before. So please don't expect any complexity, which in the end isn't there. You will find that this whole thing is pretty easy to use. But we will look into the demo program now. You see there's a Cmake file at the top. Don't know if everyone's familiar with Cmake. It's a makefile generator. It has a kind of abominable syntax for describing your project. But once you learn that syntax, you can quite easily write a file which defines what executables you want to build, which source files go to them, and everything else you want. And then you run the Cmake program to build make files, and then you run regular plain old make to build your program. Okay, that's what the Cmake file is for. We're looking into this in a minute. And then you have a bunch of files which begin with demo, a demo main, which obviously contains the main function, a demo HPP, which obviously contains a header file, which all of these files use, and 3 plugins, demo bird, demo cat, and demo dog. And as you see, we are doing 3 plugins here, and we're doing something with those 3 plugins. Let's have a look at the header file first. And before we look into the header file, let's answer one general question first. What is a link time plugin technically? Okay, I've explained before what it's good for and what it's usable for and what it's on an abstract level, but what is it technically from the compiler's point of view and from a C++ language point of view? And the answer is a plugin is a C++ class. And that class is derived from a particular base class. And the base class, it's an abstract base class, and it defines an interface. Okay, so the abstract base class defines a bunch of pure virtual functions, and these are the operations to supply on your plugins. And every single plugin is another class derived from that plugin base class. And of course, you can use as many of these base classes in your application as you want. In this demo program, we see just one, but you can have as many of them as you want. There's no limitation. So let's now have a look at the demo header file. What we're expecting to see there is something that defines the base class, isn't it? And we actually do. Funny again, there are very few code lines compared to the number of header lines. I always like that when there's a lot of comments in a file, so lots of comments here, rather few code lines. Stuff begins in line 11, where we include the link time plugin header file. Of course, we need that. At second glance, I think we would not even need it here, by the way. But it's in there anyway, so we don't have to include it all over the place. Then line 14, we define a class called animal, and this is the example base class for our plugins. In lines 22 and 23, you see 2 virtual functions, 2 pure virtual functions defined, and that's the interface of our class. And these are the functions which are to be implemented by our plugins. Okay, it's an animal class, and an animal has a name, and it has a sound it makes. Okay, silly example here, but you get the picture. And you can make these functions everything you want. They can take parameters, and they can return results, whatever you want, just like any other function. So the interface is not restricted in any way. And there is something in line 17. Yeah, that's boilerplate. Okay, you see, it says using base equals the name of our base class. Okay, I'm not going into the details why this is necessary. You just put this in. You write using base equals the name of your base class. And if your base class is called whatever, then you say using base equals whatever. Okay, this is just how the link time plugins work. Okay, by the way, this is all C++ 11. Okay, so this whole thing will work in all modern C++ compilers, starting with C++ 11. Okay, that's the header file. Easy enough. Now let's have a look at one of the plugins. For example, let's have a look at the cat plugin. That one's even shorter. You see, in line 11, we are starting a new class, which in this case is called cat, and it's derived from the animal class. And in line 12 and 16, they define these two functions, the name function and the sound function, and that's the implementation of this plugin. And of course, you can do this in any complexity that you want. You could call functions from other files, from this file. Everything is possible in these functions. There are no restrictions to that. Sorry. And line 21, that's another boilerplate line, the second one. Okay, so you need two boilerplate lines. And the second, we've seen the first one before, and this is the second. You just write register plugin, and then you specify the name of this class. So if your plugin is called class whatever, then you say register plugin whatever. You just repeat the name. This sort of links your plugin into the plugin infrastructure. And this is all the boilerplate you will ever need in this system. And this is how you define a plugin, and that is all. You don't need any more than that. And you don't have to register your cat class anywhere else. In fact, no other bit of code will ever know about the cat class. Yeah, and that's obvious, isn't it? Because the entire thing is in an anonymous namespace. Yeah, look at line 10. The cat class isn't even visible outside this file. It's not possible for any other bit of code to just define a cat object because they don't know about that class. It's just confined to this particular file. And that's what I meant when I said isolation is important. It can't get any better than that, right? You know, this plugin, this cat class is perfectly isolated from the rest of the application. You can't even make a list somewhere which iterates over your classes by explicitly enumerating them, as I did in the first code example, where it would do this if-else chain. It's not possible. The cat class does not exist outside this file. Okay, but in some way it should exist outside the file, right? Because how are we going to use the plugin if it's not? Yeah, that's just the magic in the register plugin. We're going to have a look at that later. But this is how it works. Okay, let's have a look at the other plugins. For example, the dog class, and have a look now when I change.
I'm sorry, we have a comment in the chat.
Yes, please.
Roy, do you want to comment yourself? You can just unmute.
Hey, hello. Hey, can you hear me?
Very faintly.
Sorry. So I was just saying that this is all very nice, great. I would, in just a matter of style, I think the fact that register plugin only receives one argument of cat, it's very short, but I would actually think it can be more readable to also add the animal as an argument to the register plugin to say that I'm registering the cat as an animal, and then maybe I could get rid of the using base equals animal in the header.
Sure. That will not work. No, that will not work because of the way the whole thing works. That's not possible.
Okay, thank you.
But I think that will become obvious once we look into the actual thing and look at how this thing really works. I mean, who knows? Maybe it is possible. Maybe you find a way to make that possible. So now we have 2 lines of boilerplate. If we could cut this down to 1, that would be even better, of course. I don't think it would be possible, though. But just have a look into it. At the end, by the way, I want to have a very short look into this link time plugin header file to give you just an impression of how it works. I'm not going to go into the details, but maybe then it will already become obvious why this is not possible. At least I think it isn't. Okay, does that answer your question so far?
Yes, very much. Thank you.
Okay, thanks. Okay, let's have a look at the other plugin, the dog plugin. And now when I change files, maybe you can see on screen what actually changes. Yeah, of course, only the name changes, the dog changes, the sound changes, and that's it. All the rest is identical, and the bird is also the same thing, because those plugins are exactly identical. They're 3 plugins which just do the same thing. And yeah, that is everything. That is how you define those plugins. Now let's have a look how they are used before we have a look at how the whole project comes together. So now we've seen the header file, we've seen the 3 plugin files. Let's have a look at the main file. And that's a very simple main function. Again, in 9.9, it includes the header file. And the main function iterates over the plugins, and it invokes the 2 functions on each plugin. Okay, and line 12, okay, you could also call that some sort of boilerplate. You see, we're iterating over something called link time plugin, plugins, angle brackets, animal. Okay, yes. If you don't learn that by heart, and even I can't do that, you just copy it from somewhere. And I don't memorize that stuff anymore. I just copy it across from somewhere else. This is how you iterate over all the plugins of the animal base class. Okay, and the animal object here is a pointer, as you see in the next line, line 13. And what we do there is we see out the name of that animal, and then we output the sound of that animal. Okay, this is the whole thing we are doing here with those plugins. And of course, you could run every function you wanted inside your plugins. This is just a very simple example. 2 functions, identical prototypes, no parameters, just a string return, but that can be anything you want. You can use any interface you want, and you would just pass different parameters, do a different thing with the return value here. Okay, now that's simple enough. And in a minute, we're going to see this whole thing in action and see how the program runs. There's just one thing to look into, and that is how the whole thing looks, how the whole thing is built together. That's the build configuration. As I said before, I wanted a plugin to exist essentially in 2 places. I wanted the plugin implementation to exist, as of course it must exist, just in 1 file. And we've seen that in the bird, cat, and dog files. And secondly, I wanted to have a build configuration which says which plugins go into which application or firmware version or whatever you want. And that's the second one we're going to look at this now, and that is the Cmake configuration. Well, that doesn't look so bad, does it? Just said the Cmake syntax is quite horrible. Well, in this case, it isn't. It's a very simple file, so in these simple cases, even Cmake is quite nice. It gets quite horrible when it gets more complicated, believe me, but in this situation, it's quite okay. You see, lines 5, 6, and 7, that's just Cmake boilerplate. You need these to get Cmake running. And then we have 3 lines called add executable. So we create 3 executables, demo 1, demo 2, demo 3. And there's a list of files following. And for each executable, we say which source files go into it. And as you see, each of these files has the main file, of course, and varying combinations of the plugins. So program demo 1 gets the cat and dog and bird. Demo 2 gets just the cat, and demo 3 gets the cat and the bird. Okay, I think the bird won't like that. But anyway, this is how you put your programs together, and this is the only place where you make any decision about which plugins are in the application. And if you have just a single application and you want all the plugins in there, and you don't need all this sort of dynamics we have here to have some plugins some of the time and not at other times, you want them all in all the time, it's still very useful because it gives you this isolation. Okay, you can iterate over some source code without having to explicitly list the source code all over. Okay, now we have seen everything there is to see. Now let's build this project and see how it works. Okay, and the way you do this is you create a build directory. For those who know Cmake, this is nothing new. Cmake supports out-of-source builds, so all your build artifacts go into the build directory, and you can just clear the build directory and then everything's gone. They don't mix with the source in one directory. So we're now in the build directory. You run the Cmake program and give it the name of the source directory. Okay, now Cmake does its thing. Cmake has now built a bunch of files, which are make files, which you really don't want to look into. Now we can run good old make with a parallel build option to compile everything. Okay, and it has built 3 executables, demo 1, 2, and 3. And here they are. So let's now run them. Demo 1. Yeah, and this has all 3 plugins in it. Demo 2, that's just the cat. And demo 3, that's the cat and the bird. And yeah, that is it. That is how the whole thing works. And well, I admit that's a very simplified example, but it gets the job done. And in fact, in your source code, in your real application, it doesn't really get any more complicated than that. And that was very important for me when I developed that. I wanted a very simple solution which puts all the complexity into the implementation of the infrastructure, which would be the link time plugin header file, and only the bare minimum required complexity in the actual implementation. Which I think we achieved. Finally, I would like to have a look at the link time plugins header file. I am not going into any details here because it would be very boring if I explained you all the stuff going on here. It's got a bunch of helper classes, a bunch of template classes, and whatever. And I probably forgot half of how it works. I wrote this some time ago. This is the kind of stuff you write once and you use a couple of times, and then you say, okay, it gets the job done, and you forget about it and never look into it again. But let's have a look at it anyway, and let's have a look at the end of the file first. You see, it's just 140 lines, and down there we have the register plugin macro. Okay, everybody knows you're not supposed to use macros in C++, but I found no way to do this without a macro. This is one of the places where macros are definitely useful. And here you see how the whole thing works. And before, we've been wondering, how does the plugin manage to get out of its anonymous namespace? You see, that was the big question. And the idea is that the register plugin line creates a static object. And you know, static objects, okay, they are visible only within their own anonymous namespace, so you can't access them from anywhere else. But static objects are created by the compiler, and they can have a constructor, and the constructor is automatically run before the main function. You don't have to do anything else to run the constructor of a static object. It just happens simply because that object exists. And what's even better, those constructors run in a thread-safe manner. So if you do this in several threads, we will be enlisting all those plugins in some way. And you don't have to be afraid that this breaks because of some concurrency issues. C++ guarantees that this thing is thread safe. Okay, so looking into this line into detail, we define a static object called X double hash registrar. So the double hash, that's this token concatenation thing, which you can do in the preprocessor. The X is the name of the plugin. So that would be cat or dog. Okay, so the name of the object is cat registrar or dog registrar. And the type of the object is LinkTime plugin registrar of the cat class. So LinkTime plugin is the namespace, and registrar is a template class defined within the namespace, and it's instantiated with the class of our plugin. And that's the type of this static object. And this type contains a constructor, and this constructor registers this object. So it takes the pointer to the static object and puts that into some list. And this list is depending upon the name of the base class. And that's where this base term is used for. You saw those using base equals something, and that's where this thing comes into play. Okay?
Wolfram?
Yes, please.
Hey, I wanted to ask, so if I recompile a demo1 program multiple times, will the order of the plugin registrations and the plugins that will be printed, will it stay the same?
The order is essentially undefined. Or let's call it, probably implementation defined. It depends on the order in which the compiler decides to call the constructors, and you have no control over that. I actually had a sorting function once where I needed to bring those plugins into a particular order. In most applications, that's not necessary. So the LinkTime plugin class doesn't do that automatically, and it uses a vector to store those pointers. It doesn't use something like an ordering set or any other ordering container to force ordering, just to avoid the overhead, because mostly you don't need it. So essentially, you have no control over the order. I think what we've seen before is that the order was identical to the order in which the plugins were in the Cmake configuration. But of course, that cannot be guaranteed either. The compiler can run them in any order as it wants. I don't think it's even guaranteed that you will get the same order across invocations of your program. You probably will, but there's no guarantee about that.
Okay, thank you.
Okay, so what the constructor of the registrar class does is take the pointer of this object and put it into some vector, which then depends on this plugin base class. Okay, and that's essentially it. Let's scroll around a bit just to give an impression of how this thing looks like. Yeah, this is templated code, and I think templated code is never beautiful, always very impressive. Yeah, and look, like line 92, where you have these open parentheses, close parentheses, open, close. That looks quite nasty, doesn't it? Yeah, kind of makes me, I don't know if it makes me proud that I've written that. It doesn't really look nice or readable in any way, like line 82, okay, yes. Anyway, you don't have to understand that if you want to use the LinkTime plugins, fortunately, because I think I don't understand all of that anymore. Anyway, but yeah, it gets the job done. By the way, I stole the basic idea of having this registrar and the proxy class of something. I stole that from the Boost test framework. Some of you, the question? Somebody just tapping their hands. You may know the Boost test framework, which does a very similar thing. To add a test case to your unit test suites in Boost test, you just implement them as a plain C++ function, and you begin the function definition with some macro. And that macro does essentially the same thing. It creates the registrar class and it puts your unit test function in it and somehow registers it so that later the main function of the Boost test program can iterate over them. It's exactly the same idea. And that's where I got the idea about the name registrar from. I didn't really copy the way Boost does it because it wasn't totally usable for my purpose, so I refactored that a little bit, but the name has stuck. Okay, and I think that's it. That's all I have to show you today. And now looking forward to some questions, and I'm looking forward to, everybody finding this useful, and maybe you can use this for yourself. And if nobody else has a question, maybe let me ask you, do you think this could be useful for you? Do you think you have some applications, or do you think, well, this is totally exotic bullshit and you could have had this a lot easier?
Hey, this is very cool. And the place where I work, we have something similar as well. Can you please maybe open the LinkedIn plugin HPP again?
Open which, sorry?
The LinkedIn plugin .hpp.
Okay.
Yep. And I saw that there was this unique pointer to a vector called registrars underscore.
Yes.
So I wonder, yeah, you're in 982.
92, yes.
Oh, sorry. Oh, wait, I'm trying to, yes, I think that's what I want. And even if you can you scroll a little bit up, a little higher? Yes, and 74, you can see it as well.
74, yes.
Yeah. So my question is, when is this unique PTR initialized? And if there's how do you manage the risk of your registrars themselves, their constructor happening before this is constructed, etc.?
That is because it's a vector of pointers and a unique pointer to that vector. This is to solve essentially the problem you are mentioning. For example, one question is, why didn't I put just the vector in here? And why do I have a unique pointer around it? And the answer is, if it was just a vector, then the vector would have a constructor, and the constructor could throw an exception, and I have no chance to catch that. So that's why I put in a unique pointer in here. The unique pointer constructor cannot throw an exception, so this is fine. But the next question is, where is the unique pointer actually set to something? And we have that right up here in, okay, let me get this right. Right here in line 41, you see, this is the constructor of the registrar base class. And this is a template class instantiated with the base class of our plugins. So we have this once for every plugin type, so to say. And what the constructor does in line 41, it checks the unique pointer if it has already been initialized, and if it hasn't, then line 42 creates that vector. And then line 44, we do the actual registration. If any exceptions happen here, well, yes, sorry, we can't do anything about that. Because this is running before the main function, so we cannot catch any exceptions here. We can't throw even, because we don't want to throw before the main function. So we just let it be and handle that at some other point. For example, line 62. Okay, let's see line 59. That's the plugins class. That's what you call from your application to iterate over the plugins. And line 62 checks if the registrar's pointer, that's the unique pointer to the vector, if this has actually been initialized. So if the vector constructor in line 42 fails, the program will behave like there were no plugins. And you have no chance to find out why, but normally this will not happen. By the way, we are just creating an empty vector. This will probably not fail for any reasonable reason. So this is nothing that could realistically happen. But I think the if in line 41, that's the answer to your question. And another question is, how do we prevent that from creating a concurrency problem if we are doing this across threads? I don't think that problem really arises because there are no threads before the main function, because there's no way threads could have been created. But anyway, C++ guarantees that these constructors are actually invoked in a thread-safe manner. So we're not having a concurrency issue here.
Excuse me. I just wanted to see how you use this for the endpoints of your device. Like there is no one single function that you can override there. Is there?
Yes, there is. If we have a look at the presentation, like this, let's see. Should have stayed here. I think what you mean is this thing, and the suggested implementation was something like this. And you see, what we have here, what we are using here for each endpoint.
Yes.
Sorry, I didn't get that.
Yes, that's exactly the question, yes.
Okay, so what we are doing per endpoint here, for every endpoint, we just need the name, and we need a function. And the function has an interface, so it gets no parameters and returns an integer. And that's exactly the interface we need. And in the suggestion I was having here, you can actually see that the syntax is different, but here you see we iterate over things which have a name and an execute function. And that would be the interface of this plugin class. You see, in this cat class, or in this animal class I showed you, we have the name function already, which could be exactly the same thing. And the execute function would simply have a different interface. It would return an integer instead of a string. And you could even posit some parameters. In our application, we do get some parameters in some certain unified structure. You could, for example, use a JSON string or JSON object. In our application, we're using protobuf. So we pass in some protobuf pointer. And in the end, all the endpoints have an interface which is identical. Of course, the implementations are vastly different, but the interface is identical for all the endpoints.
Okay, thank you.
This is Andreas. I would have a question about the link time plugin header in line 80. Could you open that, please?
Yes. Yes, here we go.
Yeah, 81 and 82. This is like the global object where everyone registers in, and
yes,
I'm wondering, how do the different compilation units agree on who creates this global object?
The compiler does that because this is a global object instantiated based on the base class. So that would be animal in the example. So you get one of these objects. You can see that right here. Yeah, that's where it begins. That's the actual the class, yeah, and it's the static member of a class. And here inside the class definition, line 74, you see the declaration of the static object inside the class, and line 82 is the definition. And this class exists once per plugin type, once per base class. And that's how the compiler creates that thing.
I'm just thinking it also exists several times per base class. So for example, dog CPP contains that, and cat CPP contains that as well. So somehow, I'm not familiar how that works. Somehow the linker has to see this is 2 times the same thing and has to identify them.
It somehow manages to do that. It's strange, yes. It looks like a violation of the one definition rule. In some way, it doesn't. I've tried this on a lot of platforms, and it works. I never got multiply defined anything. Yeah, I'm not a language lawyer, so I don't know chapter and verse of the C++ standard, which says why this is okay, but it is, yeah. For some reason it is.
Yeah, thanks a lot.
Yeah. It works, I think, because it's a template, okay? And there's a specific ruling about this being a template. And as of C++, I think maybe 14 and 17, you can also do it for non-templates if you write inline in the declaration.
Yeah, thanks a lot.
Okay, you're welcome. Okay, any other questions? Okay, that doesn't seem to be the case. So thank you very much for your attention. And if you find this useful, just drop me a line. Yeah, you can reach me on Twitter and LinkedIn, and all that stuff is in the presentation. And I think this will be mailed around, already has been mailed around in Meetup and on Twitter. And yeah, would be nice to hear from you if you found this useful.